Welcome back. It's me, Mr. Treewin, here for another lesson in geometry. We are looking at the last section of the unit on similarity, and we'll be focusing today on two theorems. The first being the side splitter theorem, which, again, these are shortened. I always kind of make these definitions as short as possible. I try not to use the really long ones due to board space. So the side splitter theorem says, in summary, it just says if you have three lines or more that are parallel, then the transversals create proportions. So when I look at a diagram like this and I see these parallel lines going back and forth, and then I have these transversals, these lines that pass through or intersect these parallel lines, they create proportional segments. Each of these segments is now proportional, not equal, proportional. This whole unit we've been focusing on proportions. So when I go to solve this problem, I'm always going to keep in mind that everything's proportions, which means it's always going to be a fraction compared to another fraction. So I've just got to set two things equal to each other and figure it out. So if I start with the first one and I look at the letter x, the way that I would prefer that most of my students would do this, and the way I prefer to do these problems, is I always try to play a matching game. And so when I look at this one right here, I see that x is on this position right here. I'm going to look for what corresponds to that on the other one. So in this case, I have x here, and on the other side, I have 24. So my proportion is going to be x over 24, and then I need to find another set of equivalent fractions. And that's where I'll look over here and say, all right, well, 72 goes with 60. And so I can start creating my proportions. So when I look at this, these should be equivalent. I get my calculator, I start doing my cross multiply. I've got 60 times x, 60x, and then I've got 24 times 72, which I should know off the top of my head after doing this all day, 1728. And when I divide both sides by 60, I get 28.8. And that's an exact number. It's not a rounded off, so I'm going to put an equal sign. Now, that's not the only way I could have done this. This is just my way of doing it. My preferred way is I try to play the matching game, and the same with my students to try to keep it simple. You could do other things and you're going to get the same answer. And I'm just going to throw a couple at you here. For example, if I had gone x over 72, the top one over the bottom one, then I would have to match that over there and say 24 over 60. Well, if you look at the cross multiplication, I'm still doing the same thing. I'm still going to go 60 times x, and I'm still going to do 72 times 24. I can do this 4 different ways, and they all come out to be the same answer. The only catch is I got to keep a pattern. So I went left or right over left, or I went top over bottom. Just keep the proportion, or keep a pattern. Don't be all over the place, and you'll be fine. All right, and again, that's called the side splitter. The second part of that is I have one down at the bottom. I'm supposed to be solving for y. And when I look at this, because all of these lines are parallel, I can use the same fraction I used before to figure out y. I can say y over 20 is going to equal, but since I'm on the left over the right, when I go to do those same things, I need to do 60 over 72. So that's going to give me 72y equals 1200. Divide by 72, and I end up with, let me do that for you. Oops, 1200 divided by 72, and I get 16.7 rounded off. So I've got to put an approximation. Now, that wasn't the only way I could have done this. I could have done this another, like 5 different ways, 6 different, I don't know how many different ways, but another thing I could have done was, since I know that this is 28.8, I could have done this just the same. I could have said y over 20, and then I could have said 24 over 20, 8.8. If you cross multiply that, as we did in my classroom today, we all got the same answer. It ends up being the same thing over and over. The other thing you should know about this is, because everything's proportional, if you were to take, for example, 60 and divide by 24, and then you would get, I think it's 2.5, and if you do 72 over 28.8, it's still 2.5. you get the same number either way. And that's a good way to check that the answer you have is correct. Just plug it in and make sure that these two come out to be the same as these two when you get your calculator out. All right, the next theorem that we're going to look at is called the angle bisector theorem. In this one, what we're going to do is we're going to take and create a segment that bisects the angle. Now, a lot of students often think that that makes this one equal to this one because they think bisect makes them equal. It does not. The angles have been bisected into two equal parts, not the segment. The segment's not equal, it's proportional. So all I know about this is, I'm pretty sure, based on the 30 and the 20, that this is not 12. It's proportional, so I have to create that. So again, I'm going to go with my pattern, which I like to start with the variable first. I always like to start with a variable, and I just find who matches the variable in the other side. So x matches with 12, like 20 should match with 30. And when I cross multiply, I end up with 30x equals 240. Divide by 30, x is equal to 8. And again, I want to be able to check my work. That's not the only way I could have done it. I told you in the last one, I could go x over 20 and 12 over 30, and I could do this for a while. They all cross multiply the same, but one thing I would like you to do is always be able to check your work. And one way you can do that is if you take 30, for example, you say 30 divided by 20, you get 1.5. Well, guess what? When you divide 12 by 8, you also get 1.5. And that lets me know that this, I've kept the correct proportions because they both match when I divide them out on a calculator. So it's a good way to just check your work. All right, so taking that up a notch to a side splitter problem that's a little bit more higher level, probably the one that we'd be more likely to see on a standardized test like the FSA or whatever. And by the way, I left the answers up from last period, so I'll just have to erase that. But the way you would solve it is the exact same way. You're going to match, but then people get a little confused because I say always start with x, and I've got two of those. So you'll have to just get over that and say, all right, I'm going to start with my left, x plus 1 over, and then again, I like to go with what corresponds in the same position. And then 12 over 8. So again, my pattern was left, right, left, right. Now, when I do my cross multiplication, I have to remember that this is not just x. This is a quantity. So when you do your cross multiplication, you're going to be using the distributive property. 8 times x is 8x. 8 times 1 is 8. Now do that again. 12 times x is 12x. 12 times negative 1 is negative 12. All right, I have letters, I have variables on both sides, and if you're in my class, you'll know how much I hate that because I always want to make sure that I clean that up quickly. And I always start with having the variables cancel first. So when I see these two, I immediately go for the one that's smaller, and I get rid of it. And I say 8 equals 4x minus 12. Well, if I add that 12 on over here, I get 20 equals 4x, x equals 5. Well, plug that in. Verify your work. Always check your work. If I plug that back in, 5 plus 1 makes, I'll just write right over it, that makes 6. Same thing over here. 5 minus 1 equals 4. Can you see the connection? 6 divided by 4, 12 divided by 8, it's the same number. Same thing here. 6/12 is another way of saying a half, just like 4/8 is another way of saying a half. All right, last and final example to make this video, and I want to kind of keep this one short because we have a lot going on here, and to draw it all out takes up a lot of space. On this one, I see this is another example of an angle bisector. So I know that I'm supposed to be comparing this segment to this segment, but the problem is this is left blank. Well, I need to write an expression to fill in here. So if I think about the whole thing being 13, and then let's say I threw a number at you and I said, hey, this part here is 5, you would immediately come back and say, well, that makes that 8. And the way you would come up with that is you'd say, oh, well, this one has to be 13 minus that. Well, I'm going to use that but as an expression. I'm going to say 13 minus x. Because I don't know what this is, and I don't know what this is, but I know that this is how they're related. Well, when I make this into a proportion, I now have and again, I gotta remember that this right here is a quantity. It needs to be in parentheses, and I need to remember to do distributive property. So right away I got 16x, 10 times 13 is 130, and 10 times negative x is negative 10x. Taking a step back, I see I got variables on both sides. Get rid of the small one. Get rid of the 10x negative by adding it. And I get 26x equals 130. Divide by 26, x is equal to 5. Check your work. You don't want to miss a problem like this. These problems are way too easy to be missing on a big test because of a tiny error. And the way they're so easy to check, you shouldn't be, you have no excuses. So if I plug this in here and I get 5, over here, 13 minus 5 would give me 8. And that should ring a bell to you. Look at this, 10 over 5 is 2. 16 over 8 is 2. I know that this is all proportional because I've checked my work. I hope this helps. Have a great day, and I hope this gets it done for you. Bye.